Hello and welcome to Data Science for Ecologists in R. In the last video, we introduced the linear model and its assumptions. Today, I would like to take a more practical perspective. In practice, we usually have a dataset at hand and want to find a good approximation of the relationships in the data. In other words, we try to find a good model for our data. So the first thing we must ask ourselves is, how do we come up with a potential model? The answer is the topic of today's video. We fit a model to our data. And since we are currently dealing with the linear model, we will look at an example where we fit a linear model. So what do we mean by fitting a model to data? The first step of fitting a model is choosing which model we would like to fit. In the simplest case, we could just choose a linear model, but we could also decide that we need more complex models to adequately represent the relationships in our data. In the second step, we must estimate the parameters of the model we chose based on the data we have at hand. As an example, assume we have the same data as in our previous video. Remember that we generated this data according to a predefined linear model. So we know the true parameters, but let's for the moment pretend that we don't. Looking at the scatter plot, we might decide to fit a simple linear model, which we know has the form y equals beta 0 plus beta 1 times x plus epsilon, where epsilon is normally distributed with variance sigma squared. Now we could go ahead and use a statistical software like R to calculate the parameter estimates based on our data. If we did that, we would find that our estimates are beta 0 equals 4.13, beta 1 equals 0.3, and sigma squared equals 2.9. And just like that, we successfully fitted a linear model to our data. Since in this case we know the true parameters that were used to generate the data, we can compare them with the estimates. Somewhat unsurprisingly, it turns out that the estimates are not perfect. This is because they are calculated based on a random sample. If we drew another random sample, we would also expect different estimates. Therefore, we should not blindly believe what our fitted model is telling us. Taking this uncertainty into account is a slightly more advanced topic. So first, we will learn how to arrive at parameter estimates, which will be the topic of the next video. See you soon!